Good morning, good afternoon, good evening. My name is Pieter Humphrey. I'm a consulting product marketing manager at Pivotal, and I'm joined today by my colleague Rohit. Rohit?
Hi, this is Rohit. I work for Pivotal Cloud Foundry Solutions as a solutions architect, installing Cloud Foundry and migrating applications to Pivotal Cloud Foundry.
Great. Well, we're here today to talk to you about breaking the monolith and how to do exactly what Rohit and his colleagues do all day long out of client sites, which is migrating your legacy portfolio to the cloud with Spring and Cloud Foundry. So let's just start with a predicate and espouse what we believe in terms of our view on monolithic architecture. We really do believe they're an appropriate early stage choice, but they tend to outlive their design as they become more successful, as they scale, as more developers and more architects need to kind of work on the same code base. Many of you have heard this before, but important to recognize that they really are an appropriate early stage choice at the earlier points in an application lifecycle. The realities, though, when we're out at client sites, we often hear from our customers that the portfolio they have to manage is very complicated. It's not well documented. It's a mix of a lot of different technologies, often very tightly coupled code, very complex tangles of dependencies. And a lot of their people are spending their days working with that legacy technology because of that complexity. And so it inhibits them from picking up new skills. We really believe that Cloud Foundry is just a very comprehensive native platform to build a future on, and that you're going to get value by building apps on it. And you're going to see, more importantly, you're going to see more value by moving your existing applications. So what does this look like? Let's talk about the journey at a very high level to start, and then we'll kind of progressively dive into more and more layers of detail. We start with what you have today, right? Your existing era, your existing apps running on sort of the current era stacks, right? 3-tier architecture. And what's the first step beyond that is what we often call replatforming, or just getting it to run on a cloud-native environment like PCF, Pivotal Cloud Foundry. This is looking at the bare minimum of sort of 12-factor violations, file system access, and things like that to just get it to flat out work. Right, you're not breaking apart a monolith at this point. You're just trying to make it work and run, the bare minimum. Then I think at another stage, you're looking at what we like to often call modernization, where hey, this runs well on a cloud-native environment. It's using most, if not all, of the 12-factor principles, and is starting to touch at concepts like test-driven development and maybe even some CI. And better optimizing it for PCF. Next stage, you're looking at, hey, let's make this run great on a cloud-native environment. You're looking at operational and organizational transformations, looking at cross-functional teams, looking at continuous delivery, and using more modern end-to-end principles. And then ultimately, where you arrive at cloud-native, where you're doing all of these things. Again, each of these steps, of course, building on the other. And you ultimately arrive at a microservice-first design, API-first type of design, and you're really doing the business capability team type of organizational structure and approach to building these sorts of applications. So at a high level, that's kind of what it looks like. How do you choose candidate applications? Rohit and I hear this all the time around choosing those applications is very difficult. When you've got business factors to consider, you've got the cost, you've got technical factors to consider. It's not simple. You've got to look for what's business critical. How much risk can you afford to take? How often do these applications change? Do you have the right sort of people to work on them? What are the licensing costs? How much is that going to inhibit your time to market? And then, of course, on the technical side, I think we're going to be covering that in a little more detail in coming up slides, so I won't spend too much time on it now. So the model, we've described it at a high level. Let's get into a little bit more detail. Most of you are probably familiar with the 12-factor concepts. We'll discuss that in a little bit more detail if you're not, but start off just to make something and make an application run on the cloud, right? You're really looking at, because you're in a virtualized or containerized environment, you're looking at roughly 4 out of the, 4 to 7 of the 12 factors just to get it to run, depending on what your app has been coded to use, right? So make sure there's no local file system access because you're in a containerized or virtualized environment. Replace that with S3 or something like that. Also, you want a self-contained application. You want platform-managed ports and addressing. You want to consume off-platform services for persistence, things like databases or messaging systems or other sorts of cloud middleware or cloud services. When you step up from just making it work, right, and let's look at making it run well. Well, what does that mean? That means typically going after all 12 factors, and I'm going to get into some detail on those in a slide or two. But that's going the whole rest of the way. And what's the benefit is you're getting, the cloud scalability. You're getting horizontally scalable type of platform, and you don't have to write a lot of the non-functional requirements yourself. You get things like high availability and fault tolerance and reliability. Continuing to move up from that, you're starting to get into, okay, let's look at some of the more advanced platform automation to make it run great on the cloud. Let's look at doing continuous integration and continuous delivery and the tools and methodology and software methodologies that come along with that. Often concepts like Agile XP and test-driven development. Your apps, you want them to be unaffected by service failures. And ideally, you have things like monitoring and metrics built in, and even better, you have a cloud-agnostic implementation so that you can choose to run this on whichever sort of infrastructure service that you'd like. Ultimately, you're looking at cloud native, which I spoke about on the previous slide, right? You're getting into true microservice architecture and principles and kind of an API-first design, both for your application and for the data. So I think that's an important thing to know. So why would you even bother, right, migrating a monolith to PCF? Why would you do that first step there of just making it cloud ready or making it run? Well, we talked about it for a moment, but you're getting that portability. You're getting a lot more operational efficiencies, right? You're getting a real way to reduce ops headcount through features and capabilities like the ability to auto scale, handling spikes in workloads in a more automated fashion. Operating system patching is automated, upgrading, lifecycle management. There's a lot of reasons that monoliths themselves will run quite well on PCF, and it's part of the reason why we make that predicate right at the beginning of the presentation of they really are an appropriate early stage choice, and are run perfectly well. There's some other benefits here that you can see, but in the interest of time, I'm not just going to read the slide. Let's get into a little bit more detail on how do we get started, right? Where do you actually engage? And the traditional ways of where do we evaluate getting started is, okay, let's look through our whole portfolio, let's do a bunch of design, let's think about our migration path, do some testing, and then ultimately get these things accepted. And those tend to be long projects, right? They big budgets, and the failure is slow. It takes a lot of time and money to see those problems. The value is, of course, also slow. And so that's a little bit more of a waterfall-y sort of approach, right? And we prefer to, we say, hey, start down here, right? Just make it run on the cloud. Do the minimum necessary to get rid of or refactor blatant, 12-factor violations that, just make it incompatible, right? And then work up from number 2 all the way up to number 4 at your own pace and as requirements dictate. And do that in a style that is, you don't plan everything out waterfall style up front. Start small, right? And let your work actually inform the strategy. So you work a little bit. This is the classic Agile sort of approach of things, right? Work a little bit, see what comes up. Do another planning sprint. Do a little bit more work. So how do you get all the way from just making it run and getting up to actually full cloud native and microservices. Okay, well, let's go into a little bit more detail now on the 12 factors, because that's sort of a very early, that's an inhibiting factor early on if your application is not kind of 12-factor compliant. And again, not necessarily dogmatically having to do every single factor, right? There's some that may or may not make sense for you in that in your application and your constraints, and there's some flexibility with some of them, but there are those critical ones that are kind of more mandatory, right? And I'll delineate that in a moment. But this has been around for quite some time. Heroku published this in 2012, right? And the only real goal of it is just to teach you how to make that kind of cloud ready phase at a minimum, and use declarative formats for automating the setup, and basically having a very clean contract with your underlying operating system or containerized environment, and be prepared for dynamic scaling, and be prepared for a container management system and a full-on cloud-native platform. So, let's kind of go through these really quickly and what they mean. The color coding, I think, is an indication of what are the things you absolutely sort of need to have. What are more important, less important. The one code base, one app. That's pretty important. Obviously, you have a single code base managed in source control, right? Or you have a set of repositories that are in a common root. Look for the seams in the application and try to break things up a bit. Getting to a single code base makes it cleaner to build and push any number of immutable releases across a lot of different environments. So a good example of sort of not doing this correctly is when your app is composed of 10 or 12 or more code repos, or the converse, when you have one code repository that's used to produce a bunch of disparate applications. So try to map single responsibility principle a little bit there. Dependency management is a big one, of course. Not a required, but very definitely makes things a lot less painful, especially when you get into the microservices realm. You're doing a lot more dependency management because you've broken things down into smaller chunks, right? So that exacerbates the problem. Your classic sort of enterprise shop might rely on bootstrapping and bundling all the dependencies with the app binary. Or, in the sort of Java EE world, you have a mommy server that provides everything the application needs. A server is basically hosting all that. Most people these days are using things like Maven and Gradle in Java world, or Nugget, for .NET. Regardless of whatever tooling you're using, you just want the developers to be able to declare dependencies and let the tool ensure that those dependencies are satisfied. Just using the tool doesn't, necessarily package. Just make sure it's not being packaged up in a folder structure underneath the application itself. With build, release, run, you have a single code base that's being taken from all the way through a build process to produce a single artifact, and then that's merged with the configuration information that's external to the application, and hopefully delivered, hopefully delivered at runtime, and in some cases. This is then delivered to the cloud environments and run. Regarding configuration, this is about externalizing your configuration from your application binary, right? And it's easy to say those words, but it can be very challenging depending on how the application is built. There's a lot of solutions out there. You want to be able to refactor your code and look for those environment variables, for example. Spring Cloud provides a configuration server. There's other solutions out there, things like HashiCorp. I think I've even heard of some people using Zookeeper for some of these things. Logs really should be treated as event streams. You need a time-ordered sequence of events that's emitted from an application, because you can't log to a file in a cloud, right? So if you log the standard out, standard error, and let the cloud provider or the related tools deal with it and turn that into a stream. Disposability, obviously, again, fairly important. In a cloud process, your whole environment is disposable. It can be destroyed or created at God knows when, right? At the discretion of the container management system. Designing for this is important, right? You need to make sure you ensure good uptime if you want to get the benefit of the auto scaling. And if you have processes that take a while to start up or to shut down, they need to be separated as a backing service and optimized to accelerate that performance so that they start up in a reasonable time frame or shut down. Backing services, obviously this is marked in red as a critical, right? You can't not do this, right? So the backing service is some other external thing that your app depends on, frequently a database, messaging service, or another REST call, for example. The application, you really need to declare that backing service via some sort of external configuration, and then have the cloud platform bind your app to that service. It should be possible to attach and reattach without starting the app in an ideal world, and because that kind of loose coupling has a lot of advantages. It also allows you to use the circuit breaker pattern, which is part of the Netflix open source and Spring Cloud services when you get up to the microservice level of cloud nativity, and it allows that circuit breaker to kind of gracefully handle an outage scenario. Environmental parity, again, nice to have here. We've all probably worked in situations where that shared development sandbox has a different scale and reliability profile than the QA servers, which of course is again then different from production naturally. And keeping that environment consistency is so much easier in a cloud environment like Pivotal Cloud Foundry. You really have a die-cast cut, operating system and an environment, and you're just kind of stamping out stateless copies of them. Doing this and automating as much of the software development lifecycle as possible will help you confidently deploy smaller things and much more often, which is obviously kind of at that top tier of microservices. It becomes very important. Your administrative processes, these are things like timing jobs or one-off scripts, other things you might have done using a shell script, basically. These are totally fine in the monolithic world, but they can get complicated when you scale horizontally and with multiple instances of the same app trying to kick off a job. We are actually kind of looking at, we are kind of on the cusp of providing some task level and batch level support on PCF with things like Spring Cloud Dataflow. There's some experimental support coming in version 1.8, which will be released very soon. But that kind of varies from platform to platform, and for people that maybe don't provide that, it's something you'll have to look at. You might need to break apart the job into its own microservice with a REST endpoint for a more controlled invocation rather than, having it run on a time, on a cron job or something like that. Port binding, again, nice to have in the non-cloud world. It's very typical to see a bunch of applications running in the same container, separating each application by port number, and then using DNS to provide a friendly name to access it. In the cloud, you can avoid this micromanagement. The cloud provider will manage all the port assignments, for you, along with routing and scaling. Of course, the actual process itself, again, kind of a non-negotiable here. The original 12-factor definition says that the app must be stateless, right? But of course, state has to go somewhere, or else, you're not really talking about an application of much interest. And again, we really try to move long-running state into external logical backing services that rely on data stores like Redis or Mongo, or pick your favorite flavor here to manage what's needed. And then lastly, concurrency. Cloud Foundry and other cloud platforms, they're built to scale horizontally. There's certainly design considerations here. Again, relating to all these other things. Your app needing to be disposable, stateless, use share nothing processes. This really allows you to leverage the features like the auto scale and blue-green deployment and stuff like that. So. Beyond the 12 factors, like I said a minute ago, 12 factors, it's been around since 2012, courtesy of Heroku. A lot of things have changed. Kevin Hoffman, that gentleman that works at Pivotal, has a nice little book out via O'Reilly that you can download for free off the website, and talks about 3 new factors and sort of the API-first design. How do you handle telemetry and things like platform performance management, dealing with logs, and authentication and authorization, and having security be an important aspect of the design. So this is something, if you're in the cloud space and you're thinking about these sorts of things, you might want to consider going up to the 15-factor application, right? But free download off the site, and definitely recommend to read it. It's fairly short and easy to consume. So a little more specifics in evaluating, those things at the bottom of the stack. Of what's the bare minimum, right? For the people asking themselves, where do I really get started? What are the things I really have to deal with? If your app is accepting inbound connections for non-HTTP protocols, this is basically a list of no-nos that you need to address, right? I won't go through them all, but excuse me. A lot of it, I think, has to do with the file system. Even things like JMS from Java EE, full-blown Java EE servers. Some of these things or shared user sessions have configuration options where sometimes they can be, by default are being, put to the local file system, but they're sometimes can be configured to do different things, right? So it's something to look at there. But I think a lot of this really has to do with, at the end of the day, has to do with that file system usage. So once you've identified some of those suitable applications, work with one group. Move a bunch of applications and do these short sprints. So, do a discovery. Frame some things, start to look at, do we need to do some build package re-engineering at all? What kind of configuration can we boil out, or where do we need to pull out of and either put in a configuration server or put in environment variables? Start to look at test automation, and then looking at things like, okay, what kind of refactoring do we actually need to do now that we've kind of done a few sprints? What more refactoring do we need to do around file system usage and backing service? And then ultimately, hopefully you're getting to a CI/CD type of process where, you're putting these in, you're going through these types of activities, and you're going to end up with some quick wins that you can show your management and you can show the rest of your teams, so that they're going to believe in the process and they're going to sign up for more. And most importantly, again, just delivering value quickly, right? More specifically, when you're looking at replatforming Java apps, in terms of what Pivotal Cloud Foundry can offer you, Spring apps that don't have some of these no-nos that we were talking about before, you can go right to using the Java build pack, and you'll be quite happy. Spring Boot, Spring Framework applications, Java EE. It depends kind of how much Java EE you decided to use. If you're going full profile and you're using things like JMS or JTA, those typically have sort of no-no file system usage or other no-nos embedded in them. If you didn't go much beyond servlets, which is characterizes I think a lot of people's usage, and you're more on the web profile, or even a subset of the web profile where you're kind of more stuck to servlets, yeah, you could be doing pretty well there. And there's some community build packs that can help you, but again, they don't ship with Pivotal Cloud Foundry, and they're not supported per se, but Cloud Foundry can work with any Heroku compatible build pack. There's any kind of Java basically can be supported. The Groovy, Grails, Scala, Play, all supported by the Java build pack. If you have some kind of bizarro Java framework that that nobody's ever heard of or is unusual, you can stick it in a Docker container and that can run on psafeguard and Linux. That of course is not a panacea. Just putting it in Docker doesn't keep it from violating things like file system usage and stuff like that. You still have to police for those things, but that's another sort of catch-all idea. And then with Spring Boot, we've worked hard to make that very easy. You can use the dependency management that's built right into Spring Boot with Starter Maven, Palms, and Maven or Gradle. There's a cloud profile that helps keep your environment variable settings nice and cleanly sort of separated and very Cloud Foundry compatible. Cloud Foundry uses an environment variable called vCap services to exchange connection information and credentials and things like that, configuration between the Cloud Foundry system and the container or virtual machine that your app is running in. That's the exchange point. Your application should also be able to kind of run on PCF and on standalone Tomcat. Ideally you'd be able to run it in either place, right? For some flexibility. Spring Boot does a nice bit of packaging where you can use an executable jar. And again, there's that single binary, right, that the 12 factors sort of prescribe to you, right, is that you want to be able to package everything in one place. And then, that profile capability just makes it very easy for you to kind of, if you do have separate environments, that you can provide for those without having to do a lot of source code changes or recompilation. And then ultimately, looking at tuning your pipeline to take full advantage of boot. When you're replatforming .NET, again, it's the same things, right? It's the same concepts. And Rohit has actually done a great blog on this. The URL there is at the bottom of the screen. But since a lot of .NET applications, it's pretty hard to avoid using the console Windows service. That's something pretty much everyone will need to address. And you'll need to refactor to use the console, do something logging and tracing, and do something different there. Basically the second you mess with application host.config, that can interfere with tracing and logging and things like that. Same thing with reading and writing to the registry, reading and writing to local disk. There's a few other things there, and the blog goes into some detail. But if you're a greenfield.NET application, then great. You might be able to. You could probably use the very new ASP Core 1.0, which I think people often refer to as ASP.NET 5.0, right? But the new Core 1.0, try that first. If you're replatforming or migrating existing applications, you probably want to look at ASP.NET 4.x. And obviously your dependencies and framework requirements will sort of dictate your choice there. Now, all versions of the .NET SDK are supported by Windows Server 2012 R2. And all those versions are supported, including like 3.5, 4.5, 4.5.1, and 4.6. And I guess, just looking at Rohit's flowchart, one of the other sort of gotchas, right, is, sometimes these subcomponents, subsystems that you use, you the developer might have not explicitly chosen to do file system access or some of the other no-nos that we often refer to throughout this presentation. But the system components themselves might do that, right? So like the global assembly cache, for example, guess what? That writes, write to disk. So, something that you can't do. Having addressed those, great. You can move on to Diego, which is the code name for PCF16's and Better's elastic runtime component, which is really sort of the main core of the platform. For more details on that, check out Rohit's excellent blog there on the bottom, and let's let him kind of take us the rest of the way about how we actually get from these earlier phases of dealing with the 12 factors and into the more interesting stuff and getting onto microservices.
Great, thanks, Peter. So let's just get into it. The key to gleaning microservices from a monolith is to find out the seams of the application. Now, the seams of the application is a term that was invented in this famous book called Refactoring Legacy Code. The key here is to find out the seams, and the word seam is analogous to various other literature and research in this area as well. When I think of seams, I think of them as seams identify the boundaries of bounded context. Now you will hear a lot of these terms like bounded context, aggregates, and entities. A lot of those phrases stem from domain-driven design and implementing domain-driven design. This has the research on domain-driven design has had big impacts on just refactoring microservices. So to tie them all together, we have a big application. We need to figure out how to break it into pieces. What is a scientific process to go about identifying the parts to break them? One of the easiest ways to do this is to use functional decomposition. If your application hosts 5 web services, then it probably makes sense to tear each of those services apart into its own application. When it comes to microservices, I don't subscribe to that a microservices needs to have a certain number of lines of code, but it is more in terms of feature, function, and higher layers of abstraction. So things that change together should stay together. Deployment of a service shouldn't result in deployment of other services. So how do you identify these boundaries? There are multiple ways to do this. If you don't know anything about the application, a key you can derive some insights by running static analysis tools such as find bugs and PMD and so on. The static analysis tools give you an idea of the code structure. They give you They explain what is the inbound coupling, what is the outbound coupling, what is the what is the degree of cohesiveness of the code. The idea is to figure out what are the key entities, key aggregates, the key classes that are, where are the God classes, what are the domains of this particular domains and subdomains of this particular application. The other practical things to look for when you're trying to identify seams and boundaries are to look around transaction boundaries. So when multiple resources participate in a transaction, then most likely those resources belong to a similar domain, to a similar concept. Therefore, they probably make sense to be bundled together as one microservice. The other things to look for are just organizational semantics, where what happens due to Conway's law is that the architecture of an application primarily mirrors the communication structure. So you can kind of see how the layers have evolved based on what groups have developed the application. That gives you an idea of the boundaries and of the technical abstractions that have been put in place. The other things to look for when you are trying to identify seams are look for nouns and resources. If you have a ubiquitous language, or if you have domain experts for the app, ask them about the specific classes, the actual entities and the objects that constitute the application. You can also take a scenario-driven perspective, or you can look at the verbs and the operations that these classes and objects carry out. So look at nouns, verbs. If there are models that have been separated for reading and writing, that will give you, so that gives a natural separation of model, state, and command. So this lends to a more CQRS type of refactoring. And finally, you use tools like X-ray and JDepend. X-ray for database analysis, or Schema Spy. You can also look for dependency management and analysis tools. Things as simple as just running a Maven dependency tree will give you an understanding of all the dependencies, all the libraries that are baked into the project. So the last thing I want to leave you with is something that is not on this slide, which is that you can also use techniques, newer techniques like event storming, where you model the flow of events through a system and capture them as domain events and aggregates and commands, so that you can create a complete timeline of all the activities and events flowing through the system. This gives you a complete new look at the business domain, and it abstracts you from the actual software architecture and implementation. So event storming is another way to analyze the monolith, to figure out where the seams lie, and how, and to tease apart the bounded contexts that are completely meshed together in your monolith. So next is how do you now let's go one level deeper and try to understand how do you refactor, or how do you take that bounded context out of your application. So the key things to find out is who is calling, is to identify or put a fence around the bounded context, and figure out who is calling the bounded context and the areas of code that are being called out. So you want to figure out all incoming dependencies and all outgoing dependencies. There are also technical terms like inherent and afferent coupling. So figure out what is the exact coupling of your bounded context, and what are some of the other constraints around the bounded context. Does the bounded context have to stay in sync with other services in the system, right? What is the core business objective of this portion of code that is being looked at? The key, once you identify the coupling, you have a clear understanding of what is the purpose, and understanding of what events are emitted by the bounded context and are received by the bounded context. You then start proceeding, and you then proceed to create an API fence around it, and start pulling out the bounded context into its own application. And things like Spring Boot make it easy to spin up a new app. The idea is to keep the old app impact, but just create the newer feature or newer function, the newer service as a separate application, and then create a CI/CD pipeline, and then gradually route calls from the monolith to the newer service that encapsulates the context. The Mikado method. There is one more. There is another technique of refactoring code, which is what we are doing when we are primarily refactoring monoliths. This gives us a very scientific approach for refactoring code, and prevents us from getting down into rabbit holes that we cannot recover from. The technique is called the Mikado method. It proposes basically a very simple solution. So basically, for each change, you find the dependencies that show errors once you make that change. Then you create a graph that depicts these errors along with what needs to be done to fix them. Then at each point, what you have to do is that you have to fix the error and see fix that error, see if that causes more problems, and if it does, repeat the process. So essentially what it is you are trying to draw out all the outcomes of the refactoring for a particular leaf node. Once you understand all the different ways in which the dependencies the dependencies will cause an error, then you attack a particular leaf node, fix it such that now all the dependencies are perfectly fine with it, and then you start going up the tree. So it's a depth first algorithm to tackle refactoring. It's a technique, the primary value of which is, once you have identified the bounded context, in order to clean it up, in order to this also helps in terms of just navigating the code to understand the dependencies of your system. You say identify all the possible refactorings, right? Start with an individual refactoring, identify all the errors, completely flush out your domains, the error space, and then start tackling one by one. At any point in time, you have to make sure that your code is always compiling and that you completely understand the outcome. With using the Mikado method, you will never get lost when you refactor your code. Now let's talk about some of the monolith decomposition patterns that we have seen in the wild that are successful. These are more practical techniques that you would use to tear a monolith apart. When I say a monolith, think of it as a big ball of mud, various components and services talking to one another, no clear encapsulation or abstraction between various tiers, both from a technical sense and from a business and a domain modeling sense. So the key construct that there is a key concept here known as the anti-corruption layer. The ideal process for tearing apart services or for creating microservices from monoliths is to first identify a seam. Once you identify a seam and you have identified the correct context or the service to refactor, thereafter, like as was suggested in the previous slide, you pull it apart and you institute a ring or a fence around it, so that the model of the newly refactored service is not polluted or has no influence from the model of the monolith. This is where the term fence, anti-corruption layer, you can also think of this as the REST API that is exposed by the newer service, right? So the idea is to create an anti-corruption layer that keeps the purity of the model of the refactored service, whereas the monolith still adheres to his own model, and this anti-corruption layer, it does the translation. Think of a translator between the English and the Spanish language, right? His job is to understand both models and map them across the two contexts. So an anti-corruption layer is extremely useful when you start creating newer microservices from your monolithic application. Strangling the monolith. So you have a seam, right? What the idea is to create equivalent functionality concurrently along with the old monolith. So now you have essentially the same function replicated in the big ball of mud and the newer service, and eventually through dynamic routing or through smart routing, and through various other testing measures like canary testing, blue-green deployment, you want to move the traffic slowly from the old feature function to the newer application. So this is what is known as strangling the monolith, where essentially you are exposing the same feature, the same service separately in this newer microservice, and then eventually sunsetting the feature in the original monolith, thereby strangling that particular feature or service in the big ball of mud in the bigger monolith. And this can only be done when you introduce an abstraction layer, and the abstraction and the monolith talks to the service through the abstraction layer. The idea of introducing an abstraction is that you will have two implementations, and eventually the newer implementation, the cleaner microservice, will be the current implementation and keep continuing in the long run, whereas the older piece of code is then deleted, or the monolith shrinks to completely remove that function. Smart routing. So this is an excellent segue into what I described earlier with strangling the monolith, in that you need to have in front of your applications, you need to have a smart application router that is able to route traffic from the older application, from an existing application to a newer application. So think existing application being the monolith, and being a particular service or API within the monolith to a newer set of applications. This can only be done if you have a sufficiently mature platform like Cloud Foundry that provides things like canary testing. It allows for scaling applications up and down. It allows for dynamic routing. So when newer applications spin up, they're automatically recognized by the Go router, and the front-end router can immediately start sending traffic to both the old app and the new app. You can map a particular route to the same external route to two applications, thereby allowing you to do blue-green deployment. These are the concepts that you need in order to implement the strangler pattern to direct the traffic to your newer application, and yet continue with the monolith. Dark launching and feature flags. This is a technique where where newer features are introduced in the code base by creating logical switches in the application that allow you to turn the feature and function on and off at runtime, right? So this gives you a way to do continuous delivery with least amount of risk. This is a concept is useful in the practical example that I was giving earlier. If a particular account service has been implemented as a newer account service, then what you could do is in the monolith you could introduce a feature flag which can be toggled on or off, and at runtime, once you are satisfied that the newer service is performing according to its SLAs, you can then dynamically toggle that feature off. This gives you a great amount of flexibility in terms of the number of features that you can expose to your users. You can control which features get exposed. It allows you to do continuous delivery in your pipelines and then release features at your own cadence. It can be controlled in a number of ways. There are also some products that have now come about that provide dark launching or feature flags. It's a combination of the platform supporting it and putting some of the configuration constructs in the application itself. How do you implement it? You can use booleans. You can rely on the number of instances of your application. You could have 10 instances of application version 1 and only 2 instances of application version 2, and direct load to the newer set of features, or control the load that goes to the newer set of features and the older set of features. You can also, when the application load comes in through the router, you can control which percentage of your user base sees those features and which percentage sees the old function. A lot of this is only possible if you have flexibility in terms of you have introduced these hooks into your application, and your application is able to dynamically and smartly route to those respective endpoints. So how does Cloud Foundry make this easy? It has constructs such as CF scale. CF scale allows you to scale the number of instances of an application. Cloud Foundry also allows you to map the same route across 2 or 3 different applications. This allows you to control the amount of traffic and load going to a certain version of the application. There are also constructs like the configuration server, where you can in Spring annotate beans of the refresh scope, and as soon as the configuration server has a newer configuration, those beans pull the newer configuration, and those could be feature toggles. That configuration can enable feature toggles and so on. So a combination of the routing and the features provided by Cloud Foundry, along with some of the using a external configuration server, as well as writing the application such that it takes advantage of these hooks, gives you an ability to do dark launches or provide features on the fly to your users. That's it. I leave. This is the last slide. We can take questions after this. If you want to try out Cloud Foundry or Pivotal Cloud Foundry, you can just you can push applications for free if you go to the Pivotal Web Services website. You can also download PCF Dev, which allows you, which is essentially Cloud Foundry in a box. Through in 10 minutes, you are pushing applications to your local Cloud Foundry instance running on your Mac or Windows VM. Thank you, and now we'll take questions.